So this is the design modular application. Once it's open, we can start to draw the geometry. So for example, here we want to draw a room. Inside this room, we want to put a human being, okay? And we want to put inlet and outlets. So first, we should create the room, okay? To do this, we can do create primitives. As you can see here, you can create several shapes: a sphere, a box, a cylinder, a cone, a prism, etc. So since we want a room, we'll select the box option. Now, we should specify details of the box. So first here, you have the name of the box. You can rename it as you like. So you can say it's the room, okay? You select a base plane for it. You can select one of the main three planes, X, Y, Z, X, Y, Z. Now, for the operation, you have several possibilities. You have add frozen or add material. Now, when you want to build a space and put something inside it, and you want to see what is inside, you put the option add frozen, okay? And now we will specify dimensions of the box. You can specify the dimensions with two types, or you can consider from one point and diagonal. So you define one point of your box and the size of its diagonal. Okay, this will give you your box. Or also another option is to define 2 points. So you select two extreme points, two opposite extreme points, and you set their coordinates. So for example, if your room has a base of 3 by 3 meters and a height of 2.6, let's say, so you will put that along X I want, for example, the first point will be 0, 0, 0, okay? The second point will be, let's say 3, 3, 2.6. And now you can, once you specify this information, you just have to click generate and you will have your box, okay? So this is your box. Now, we can zoom it, we can here use this tool, okay, to zoom in. So as you can see here, you have 3 by 3 and you have 2.6 along Z. If you want that 2.6 is the vertical height, okay, then you can change the dimensions. So if you want to have XZ as the horizontal plane and here Y represents the vertical, you can just modify here. So just you have to click here again, okay, and change coordinates. So you set Y to 2.6 and Z to 3. And again, after doing these modifications, you select generate. And then now this is your height of your room and this is base plane. Okay. So now, of course, you can anytime change dimensions. So if you want, for example, to have a larger room, you can just say, I will do it as 3.5, for example, and 3.5, and I will get my room. So you can change at any time the dimensions of your space, okay? Now, next step, okay, will be to draw a human being at the center of this room. So of course, a human being is, as a geometry, is very complex. So to simplify, we can model it by a cylinder. One of the possibilities is to model it by a cylinder. So I can also, again, do create primitives, and now I will select cylinder. Now for the cylinder, I should specify first, okay, what is the base plane. So since my base plane is the floor, then the floor is xz plane. So I will specify here that I want the xz plane, and I will put apply. And as you can see now, my cylinder is vertical. Now, I want the origin point, okay, to be at the center of the room, okay? So as you can see here, the center now is at this level. I don't want it to be at this level. I want to put it at the center of the floor, okay? So what I should do, I should move the center to the middle here. So it should have as coordinates 0 along y, 3.5 over 2 along x, and 3.5 along over 2 along z. Okay, so for the origin coordinates, for x it should be 3.5 over 2, so it's 1.75, and also along z 1.75. Now I can obtain my cylinder centered. Okay, so I can verify always if I did anything wrong by just looking at the position of my center. Okay, so what I want to have here is to have my cylinder just at the floor level. Okay, so, and I should put that the height of my cylinder should be equal to the height of the human being, which means that I should have here along z, okay, along z. Here, what they mean by z axis, so it's the axis of the vertical axis of the cylinder. Okay, the height is 1.1. Okay, so here it seems that the coordinates x, y, z are different than x, y, z of the main system. How you can know this? Because z component for my cylinder represents this axis. Okay, so here if you see that there is a certain difference between the coordinates here and the main frame, all you have to do is just to try to modify in order to get what you want. So what you want is, here I consider z as the vertical. So we can do here, if you put 1.75 and 0, you can verify if your system will work now. And this is the case, okay? Because sometimes the reference XYZ for the geometry you are building is different than XYZ for the original system. And you can verify this by just looking at the axis. So here, as you can see, always Z axis here, Z is in blue, Y is in green, and X is in red. So for your main system, the vertical direction was along Y. Now for your cylinder, okay, for your cylinder, this is the axis of reference. And as you can see for your cylinder, the blue axis is the vertical and blue is Z. This is why you can just pay attention then that the coordinate for the cylinder is different than the coordinate for the main system. Okay, and you will follow coordinates of your cylinder. Okay, so just you have to set now x and y to be 1.75 and z to be 0 to have your center just at this point. Now, what about the radius of your cylinder? How to select the radius? So we will select the radius in a way to represent the actual surface area of a human being. We selected a height of 1.1 because we are considering that the occupant is not seating. Okay, so this is why we consider the average height for a sitting occupant, which is 1.1, okay, or 1.2 nearly. And concerning the radius, we will take a radius in a way to have a surface area of the sitting occupant equal to the area of a human being, which is around 1.8 meters square. So what you can do then, you can calculate the corresponding radius. It is around 0.4. Okay, and now I can generate to obtain my cylinder. So this cylinder will represent for me the human. Now, concerning the type of operation, okay, here also you have several possibilities. You have add frozen. In case you want to build something inside the cylinder, you will select it. But here, no, I don't have anything inside it, so I will not put add frozen. You can put add material if you want to consider the whole material of the cylinder, and you can put slice material if you want to do separation between the body and the surface and the lateral surface. Okay, and here it's very important to do this. Why? Because what I am interested for is the external surface of the cylinder, which will exchange heat with the environment. I don't care here for the body, what is happening inside the cylinder. I just care for its interaction with its environment. This is why when I put sliced material, I will be able to select separately the lateral surface and the body. And since the body is not interesting for me, I can suppress it. So when I say I suppress the body, this means I will just empty it and consider its external surface. And why I do this? Because to reduce the computational time, because I don't care for what is happening inside. So I don't want to mesh the cylinder from inside and increase the number of elements. Okay, so here I will select slice material and I will put generate. And now, as you can see, if you do this, so also here you can name it as occupant. Okay. When you do the slice operation, then if you do this, so if you do suppress body, okay, you will still observe the lateral area. You will just, if you turn this geometry, you will see that it's empty from inside, because I don't care for what is happening inside. So I am not considering it to reduce the number of elements. I just consider the lateral surface. Okay. And here also you can rename your parts. Okay. And you should here select the type of fluid in this part, if it's a solid or a fluid. So for example, this is the room. So I just put rename room. Okay. And since it's a fluid, I will put here, I will select fluid for my room. Okay. And now for my cylinder, for my person, okay. So for my person, so this is, you can rename it here. This is the occupant. And we can consider here that it's a solid. Okay, so it's already set as a solid. We'll keep it as a solid. Okay, so in this way, we have defined the two parts. Okay, and now the next step will be to consider inlets and outlets. Okay, so now I want to build one inlet, one outlet, in order to have to be able to define a flow inside my room. Okay, now whenever you want to put inlets or outlets, so first you should draw them. Okay, so you should do a sketch. This is why, let's say we want to place the inlet on this side. Okay, I will do this. I will put, let's say, I will search for this plane. This plane is XY plane. Okay. I want to draw an inlet on this plane. I will put sketching. Now, the next step is to select the type of geometry I have. Here, I want to draw a rectangle. So I select rectangle, and now I can draw it. Okay. After I draw it, I should specify its dimensions. Okay. So then I will click on dimensions. Now I can specify horizontal or vertical dimensions. So I click horizontal, and then, for example, let us say I have the this length is 0.5 meters, for example. So I can specify it here, 0.5. Now, to completely define this inlet, I need to define its distance from one of the sides. Okay, this is my reference side. So I select this line and this line. And let us say this is, you already have, if you want to put it at the middle, you already have 0.5 meters. So the remaining part is 3 meters. So each part will be 1.5. So you can set it as 1.5. Okay. And now, if you feel it's a small inlet, so you can increase its length. So this depends on your geometry. You can try several configuration maybe to see what is the best application. It depends on the velocity, the inlet velocity you design. Okay, if you know the flow rate and you have a certain range of velocities, you can determine nearly what should be your area. So in general, it's better to have it large, not very small inlet. So if we see that it's small relative to the room, we can try to increase it. So for example, you can change it and set it to 0. Let's say 0.9, for example. Okay. And then if you set it 0.9, then what you should do is you should put here 1.3. Okay. So that it will be at the center. So now, after we have determined the horizontal directions, we'll move to the vertical ones. So now I select vertical and I consider here the distance between these 2 points. Let's say you have, for example, here it's a 0.6, let's say. So you specify it and you say it's equal to 0.6. And you specify the distance from the floor level. So this is the reference line. And if we have a total height, let's say of 2.6, and this is 0.6, if you have it, let's say 0.2 meters below the ceiling level, so 0.2 already, then I have 1.8. So this distance should be 1.8. Okay, so now I completely defined everything needed for my inlet geometry. So this is my sketch. Okay, now I want to draw an outlet. Let's say the outlet is on the opposing wall. Okay, so now I should draw a new sketch. But this sketch is in a different plane. And this plane is not defined in my geometry because the main 3 planes defined are these 3, this one and this one, and the plane at the floor level. So I should define the plane in which I want to draw my outlet, let's say. So if I have it on just the opposite side, okay, then I should create a plane that is just obtained by offset of 3.5 meters from the main plane XY. Okay, so I will say I want to create a plane. So I will go back now I will go back to my system. So as you can see now in XY plane, already I have a sketch. Now I should create a new plane to create another sketch. So I will go to create new plane. Okay. Now how to define a new plane? You can define it in several ways. So you can define it by its distance from a face, from a centroid, from point and edge, from point and normal, from 3 points, from coordinates of points. So you have several options to define a plane. Okay. Here we'll define it from another plane because we'll determine the offset distance from the plane XY. So the base plane is XY, and the type of transformation I want to do is offset. Offset in perpendicular direction, which is Z. Okay, offset in Z, and this offset is equal to the distance of 3.5 meters. So I'll specify here 3.5. Okay, and now I created my plane. So I can make sure, so I put generate, and now when I select plane 4, I have my new plane. Okay, and now I'm ready to draw a sketch in this plane. So I will put sketching. I will select again rectangle. I will consider that I'll have the same dimensions of the inlet. Okay, well, of course you can have different dimensions. So it depends on your case. Then let us define the dimensions. So first I take horizontal. So we said that this is 0.9. This is 1.3. Now in the vertical direction, I have the following. The vertical direction I have, this distance is 1.6, 1.8, sorry. And this one is 0.6. Okay, so now I have my new sketch. So I can go back to my system. I press modeling to go back to my system. I can verify now that sketch 2 is drawn in the second plane. Okay, so when you click on the sketch, you can see it. But if you don't click on it, you cannot see it. Now, this is why we should do a certain operation to be able to see it without having to click on it, and in order to be able to select it. Because now if you try, this is the selection tool for a face. If you try to select, if you try the selection tool, okay, you will not be able to select the sketch. It's not an independent face if you want. So I want to make it an independent face. For example, here you can, this tool is for geometry selection. Okay, you have different tools. One tool for geometry selection. This is a tool for face selection. So for example, if I press this, I can select the different faces. But as you can see, the sketch is not identified as being separate now from the wall. So when I press here, the sketch is not showing. Okay, and my purpose at the end is to be able to select the sketch because I want to put boundary conditions on it. So I should be able to select it separately. In order to select it separately, I should do a certain operation. This operation is called imprint face. This means that, as the name indicates, I will imprint the face along the surface so that I can select it separately from it. Okay, how to do this? To do this operation, I should do the following. First, I should say my system is already, if you remember when we considered the room, we selected the frozen operation. So my room is frozen. To be able to imprint a face on any surface, I should first unfreeze my system, because once it's frozen, I cannot imprint anything on it, on any of its faces. So I should put first tools, unfreeze, to perform the operation I want. And I want to unfreeze my room. So I will, when I select unfreeze, okay, I select the room body and I say apply. Okay. Once I do this, I click generate. Now I am ready to perform the operation I want. Now this operation, I want to perform it on sketch 1. So I click on sketch 1 and I put now extrude. Okay. The extrude operation will allow me to perform what I want. So I will first say I want to apply it on what? On sketch 1, and I click apply. Now, what is the type of operation I want to do? I want to imprint face. So I want to have it separate from the surface. Okay. Now, I want to do it. Okay. I want to do it on, directly on the face. So I can select here the extend type as, if you want, you can consider here it's reversed, because I want to just imprint it on the surface. Okay. So now when I do this, okay, I will just do generate. Okay. And now once I'm done, I should again do tools, freeze. Now, if we try together to select the face, we'll be able to select it separately. So as you can see, now I can select this surface, the inlet alone, and the face alone. And this is what I wanted to do. Okay. Now we should repeat the same operation for the second sketch. So again, for the second sketch, I will do the same procedure, tools, unfreeze. I select the room, I put apply, I select extrude another time. Okay, after doing generate, I select extrude another time. I apply it now to sketch 2 and I click apply. I select the imprint faces option. I select reversed. And now I just do generate. And once I am done, I do tools, freeze. And now I am able to select separately both inlets and outlets. So I just have to make sure I put the face selection. I can select the inlet separately. And now to turn my geometry, I can click here. I turn it to the side. And now I select again. Very good. So it's working. I can select separately the outlet and the surface on which I have my outlet. Okay. So this is how I draw my geometry. You can add whatever you want to your room. So for example, if you have a radiant panel, you can just represent it by a surface. If you have, let's say, if you want to add a desk, if you want to add a chair, you can do what you want in the geometry. Okay. So you are free to try to add anything in the space to make sure that you know how to perform the operation. Okay. Now, just one thing concerning the occupant. In general, I think the diameter is 0.4. هلا نحن when we specified the dimensions of the occupant, okay, they provide us the radius, not the diameter. This is why here it should be half, so 0.2 nearly. Okay, how you can make sure? You can make sure from the surface area, because when you go to the surface area, okay, you should have nearly close to 1.8. So as you can see, it's 1.63 meters square, so it's fine. Okay, so you can increase the radius a little bit or the height in a way to get the average surface area of a human being, which is 1.8. So you can try, for example, a little bit larger height. So if we go back to the occupant, if we set the height, let's say to 1.2, okay, we can see that nearly the occupant surface will be very close to 1.8, which is the average surface area of a sitting human being. Okay, so you can always go back to your geometry and change, but pay attention. If you change in the geometry, okay, you should reset your mesh. So you should generate your mesh again and repeat the procedure. Sometimes you can adjust if you want. You will not reset from zero, okay, but you have to let's say to generate again the mesh, and for the setup you can update it if you have a big modification in the mesh, in the geometry. Okay, so this is about the geometry, and the next step will be the meshing step.